Hey everyone, so this is the second of the sorting videos, and in this video I'm going to be talking about merge sort. I'm going to go over how merge sort works, and then I'm going to go over why this particular function's runtime works out to being n log n as opposed to n squared, like a selection sort, insertion sort, and bubble sort. Now I'm not going to do a formal analysis, but I'm going to explain where this n log n idea comes from, like how can we say this about this particular algorithm. So let's, to understand how merge sort works, we first have to understand the merging algorithm. So the merging algorithm is if you give the function, the merge function, two arrays that are already sorted, you can put those two arrays together into one array that is sorted in n time, where n is the total number of values in the two lists combined. So here I have one array and here I have another array. Now they don't have to be the same size. The merging algorithm actually works regardless of the size of the two arrays. Okay, so you can merge two arrays that have totally different sizes. Okay, and it will always produce an array at the end that is sorted. So if you start off with two sorted arrays, you can put them together and get them to be sorted. So how does this actually work? Well, given these two arrays, what you're going to do is you're going to be picking out the smallest value out of the two arrays one at a time. And so imagine taking all these numbers and sorting it. The smallest number that is going to be in the list will either be the first number in the first list or the first number in the second list because they're the smallest of the two lists, right? Now, one of those has to be the smallest in the entire array because otherwise it won't make any sense, right? Because these things are sorted. So the smaller of the two smallest values will be the smallest number. So the way this works is you simply start by looking at the one element at a time through the two lists. You start off by looking at the first element each, and you compare these two numbers. So between 1 and 3, who is the smaller one? And the answer is it's 1. So you're going to put down 1 as the first value. Now, since we chose 1, we've dealt with that in this list. So we're going to instead move over to the second value. Okay, so the 1 has been dealt with, so we don't care about it anymore. So now we are dealing with the 2, and we're still dealing with the 3 over here because we haven't looked at this. We haven't dealt with this number yet. Okay, so you only move the arrow if you chose from that list. Okay, so between 2 and 3, who is the smaller one? Well, in this case, it's actually 2. So we pick the 2 and we put it aside into our new list. And we say, well, okay, now we've dealt with this, so we're going to move the 2 over to, we're going to move the arrow on the first list to the 6. So now we're dealing with 6 and 3. And this time, 3 is actually smaller. So we're going to pick the 3 and we're going to put it into the list, meaning that we've now dealt with the first number in that list. So we're now looking between 5 and 6. And again, 5 is the smaller number. So since it's the smaller number, we're going to choose it. Oops, wrong pen. We choose the 5. And then, because we chose the 5, we move this arrow. Now, between 6 and 12, who's the smaller? Well, it's 6 in this case. So we're going to take the number 6, put it into the list, and move this along. And again, between 10 and 12, who's the smaller one? Well, in this case, it's the 10. So we're going to choose that, and that's it for that list. Now, once you have dealt with every single value in the list, you're basically done with having to worry about that one list. So every other number has to come from the other list. So you're going to just simply go through the only list that's remaining and do that. There we go, done. Now, that is how that works. Now, this is the actual code for the merging algorithm here. And you can see sort of this action. There are two pointers pointing at the beginning of the two lists. So this is actually from merge sort. And then we use an empty array to sort of put this together. I'm going to show you a picture of this in a moment. And effectively over here in this code, you're basically choosing between whichever is the smaller. So if the number is smaller from the first part, then you're going to choose that. And if it's not, then, well, if the first number is not smaller, then the second number is smaller. So you choose the second number. And you put it all together like this. There's two while loops at the bottom, and this basically deals with the rest of the list. So while there's two loops here, only one of these two loops will ever run. And the reason is because you're not going to be doing, because one of those lists will be empty. So one of these conditions will have failed in order for it to get out of this loop. So this loop, these conditions are also present, and they both have to be true in order for this loop to stop. Or sorry, for this loop to continue. So if one of these conditions becomes false, then it will stop this loop and go on to one of these two. But because these two conditions are the things that are one of these would have been the one to stop the first loop, one of these loops will, the while condition will be false and you will skip it. So it depends on what the condition was. This is basically just copying out the rest of the array. Now, that's the merging algorithm. That's the code. Now, this actually comes from merge sort, so it's a little bit messy looking, but effectively, it's still the merging algorithm. It's still based on this algorithm. Now, I'm going to show you the picture of how this actually works. So, second here. Now, again, this is, you can get to the animation for this by going to the course site, going down to this animations link, and then from here, there is one on merge sort. So, oh, I'm going to pause that. All right, I'm going to restart. Okay, so the way that so now let's talk about merge sort since we've gone over the merging algorithm. Now, merge sort is based on this merging algorithm. So if I took an array and I split it into two pieces, and then I say, okay, if you sort the first half and then you sort the second half, you have two sorted arrays. And once you have two sorted arrays, you can merge them back together into one array that is fully sorted. Okay, that's really what merge sort is based on. That's what the recursive version of merge sort basically says. So ignore all of the conditions. That's just the mechanics of how to deal with this. This basically says, okay, take the first half, take the array, split it into two. This is why we're finding the middle here. Find the middle of the array, split it into two pieces. Okay, take the first part of the array and we're going to sort just that part. Okay, now remember, recursion works by magic, and what this function will do is it will sort the array magically. Just don't worry about how it's going to be done. It's just sorted. When the function finishes the first part of the array between these two indexes inclusive will be sorted fully. Then you take the second half of the array and you sort just the second half of the array. Okay, so you can do the sort on that. Once you have two arrays that are fully sorted, then what you can do is you can merge them back together and get one array that is sorted. So that's what this says. Take the first half, sort it. Take the second half, sort that, then merge them back together again. That's merge sort in a nutshell. Now, over here, this is what this animation is showing. It's basically doing the splitting. Now, code is in C++, but it's the same code, just slightly different syntax, okay? You calculate the midpoint, then you're going to sort one half, then you're going to sort the other half, and then it becomes sorted. So what does this actually do? So if I step through the code here, I'm just actually going to slow down the speed and play and talk about it at the same time. So you see how it's sorting, splitting? Once you have an array that only has one element like these two, you have a sorted array. Okay, so the splitting doesn't actually do anything. It's really just sort of thinking about the array as if it's pieces. Take the first two elements, consider them basically as being single size arrays, and then you merge them back together. So here we have two more that are being merged. And once it's merged, I have one sorted array here, two sorted array here, and now we can merge these guys back together, picking the smallest number each time, and then adding it to back into the array. Okay, next step, same thing. So splitting it into pieces and then getting two element arrays, and same thing over here. Now, so this part is basically just simply getting the two merged together. So now we have two elements array that are sorted, and we're going to merge those guys together. Okay, and now we have two 4-element arrays. These two arrays are sorted. So we're going to merge these back together, picking out the smaller number each time. So the green number is smaller and the red number is bigger. So that's what this is doing, just picking out the smaller number and then putting it all back together again. Now, this half of the array is sorted. So now we deal with this half, and let's speed this up a little bit. Again, we're just simply taking each piece, splitting it until they are sorted arrays, then merging them back together into fully sorted arrays. Here we have a 4-element and a 3-element array, but the algorithm still works. Now we have two arrays that are fully sorted. We merge them back together, and that's it. Okay, so that is how uh, merge sort works. Okay, note that you need the second array because the merging needs a place to put the fully merged array. So once you have filled this array, you copy the whole thing back into the original. That's what that is. Uh, and that is merge sort. Okay, that's how it works. Now, the reason now the animation is a little bit deceptive because it actually seems slower than like bubble sort or insertion sort, but that's just because it's showing you how it works. The actual algorithm is actually faster than any of the simple sorts. So let's consider why it is actually faster. Okay, so let's start. So I'm going to illustrate this with an example. Okay, so here we have an array, and it has n elements in it. So if I measure how many things in it, there are n things, n elements in this array. Now, merge sort says you take the array and you're going to split it into two pieces. Each of these pieces will be half as big as the original. Okay, and if one piece happens to have one more, it doesn't matter. Okay, the algorithm still works. So this will be n by 2, and this will be n by 2, okay, in terms of its length. Okay, so this is how big it is. It's not the number that's stored, it's just how big it is. And each of these will then get split again into two elements each that are a quarter of the original size. So n over 4 big each, because n over 2 divided by 2 is n over 4. So each of these are split further into quarter of the original size, okay? And you keep doing the split, okay? So there's going to be more splits. I'm not going to draw them all, obviously, but there's more splits. And eventually, what happens is you get to arrays that only have one element each, okay? So after, oh, I should draw it under. So these are, so it doesn't go from n over 4 to 1. It's a bunch of splits later. You eventually end up with a whole bunch of one element arrays. Okay? Now, a single element array is, by definition, sorted. So you then take each of these single element arrays and you're going to put them back together, merge them. Okay? And now, when you merge them, there are a whole bunch of arrays that are going to be 2 elements big each. Okay? And you merge those guys back together, and they will have 4 elements in each one as you do the merging. And there's a lot of them, okay? It's whatever n is divided by 4, by the way. That's how many of these tiny little arrays there are. And you keep merging those. And eventually, what happens is after a whole bunch of merging, okay, what you will end up with is you're going to end up with 2 arrays that are n by 2 each. 2 arrays only, sorry. 2 arrays that are half the original size, and they're both going to be sorted. Then you merge those together and you end up with one single array that has n elements in it. That's how merge sort works. Now, if we think about, so there's several things to think about. How much, now the splitting itself, if you take a look, what all the splitting is basically figuring out where the array begins and ends. There was no movement of numbers, right? And the splitting can be decided pretty quickly. So the code for that is simply calculating the midpoint, which is just this. So this is constant time operation by itself, okay? This doesn't take very much time to do, to calculate the split, okay? Now, where did it go? Oh, I think this thing crashed. Sorry about that. Force quit this. Sorry about that. Let's do this again. There we go. Okay. So this particular split, figuring out the split is trivial in terms of amount of time it takes. The merging, though, does take time. So the question then is, how much time does it actually take? So I'm going to grab this part of the diagram, and I'm going to look at this sort of separately. Shrink this up just a bit. Okay. Now, remember when we're merging, this came from two arrays that are n over 4 each. Okay. Or four arrays that are n over 4 each, sorry. So this is sort of where it comes from, right? Now, let's think about how much time this will cost. What's the cost for doing this? Now, remember, I had said that the merging algorithm itself, that's this thing, okay, this long function. This is actually an order n function where n is the total number of values in the array. So merging two arrays where each of the arrays have n over 2 elements is going to cost me some constant times n. Now, I don't know what that constant is, and if you want to figure it out for yourself, feel free. All you have to do is count how many operators there are in this loop, keeping in mind that you will either only ever do this or you will only ever do this. This if else is mutually exclusive. And so if you think about what happens is for every one of these loop iterations, I will either do if or else, okay? And at the worst case, I have to do this check every single time. But what will happen is basically there's one, two, three operators in there, an if check, 4 operators, or I will do this if check, it fails, and I do same 3 operators here. So the cost is actually the same regardless of which way you go. And you have to do this check at the top to see whether it's failed, but it's 1, 2, 3 operators, right? So it's 3 operators plus 4 more, okay? So 7 operators here in this loop. There's some constant assignments at the beginning, only 3 of them. And then you have this other loop here, which basically has 4 operators in it. And you only do ever one of these. So the worst case cost is that we have to be in this outer loop where there's 7 operations, but it's 7 times n, right? Basically, and then there's one value at the end that you have to deal with for this. That would be the sort of the worst case cost, if you will. But in any case, what we can say is that it's just some constant. It's some constant times n, okay? So the cost of doing this merging, the cost of merging these two arrays together is some constant that I will call C times N. Now, this is the cost of taking these two arrays here and turning it into this array, okay? Now, however, I can't just merge two arrays together. It only works if they're sorted, right? So before I can merge these guys into this, I have to first merge these n by 4 arrays together to get this one, and these two together to get this one, right? Now, what's the cost of that? Well, remember, merging is the cost of the sum of the number of elements in the two arrays. So in order for me to get this half of it, it's going to cost me a total of n divided by 4 plus n divided by 4, which is n divided by 2. So it's going to cost me c times n divided by 2 in order for me to get this array here. But there's two n over 2 arrays. So it's not just c times n by 2, it's actually 2 times c times n by 2, because, excuse me, it's this quarter, it's these 2 quarters plus these 2 quarters. So there's 2 of those. But this can be simplified, right? So this value is really just c times n, okay? So in other words, merging two, uh, two sets of quarter element arrays together to form an n by 2 array is going to cost me half of c times n, it's going to cost me c times n over 2, but I have to do it twice. So in the end, it's still c times n for the total cost of that level. And if I keep working this out, okay, at the next level, it would be n divided by 8, right? 2 of those each. So each one is a quarter, but there are 4 of those, so you will still get c times n. So what it means is that the cost, if we did the math to calculate this, would be some constant times n for everything, okay? So each of the levels, okay? So how many operations this will be in total is how many levels there are from elements of size 1 all the way to elements of size n, how many levels of merging we have to do. It's the cost of this merging, right? So how long does it take before I can get to n? Okay, so if I start off with an array of size 1, in order the next one level later, I have arrays of size 2, right? And one more level later, I have arrays of size 4, then I have arrays of size 8, and so on and so on. So how many times do I have to do this before I get to n? How many numbers are there? Like 1, 2, 4, 8, 16, 32. How many of this doubling pattern do I have before I can get to arrays of size n? Okay. Now you look at this and you go, how do I figure this out? Well, there's actually a way to do it, right? So if we think about it, this number is 2. Now this pattern should become familiar to you, this idea of doubling. So this is 2 to the power of 0. This is 2 to the power of 1. This is 2 to the power of 2. This is 2 to the power of 3, and so on. So what is n? N is, what is this? What is the exponent here, right? That's the question. What is the so because like there's a pattern here, right? Like this is 0, this is 1, this is 2, this is 3. What is this exponent here to get n? So 2 to what power gives you n? Okay, that's the question. Now, there's a way to ask that question, okay? 2 to the question mark n, how do I know what this is? What's the exponent? The convenient way to write this out is actually the idea of log of n. Now, quick review of math. In mathematics, they say that if you don't put the base down, this log is 10. Mathematicians are mathematicians. We are not mathematicians. We are programmers. Programmers say base 2. Okay, the base is always 2. So if you see any programmer video and they talk about log, they're not talking about base 10 log. It's always base 2 log. Okay, so this is log 2, not log 10. Okay, now 2 to what power? So this number here, log n, this will calculate out to a number. That number is the exponent you have to raise 2 to in order to get the value n. Okay, so the question mark is really equal to that. That's the exponent. Okay, so whatever this works out to, that's the exponent. Now, so what does this mean? Well, here's a question. How many numbers are there? So this is 0, 1, 2, 3, blah, 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 right? So if I think about it, the one before this would have been 2 to the log of n, okay, minus 1, because it's one exponent lower, right? So now I'm not actually even interested in calculate log of n. I just want to know how many numbers there are. So if I count 0, that's the first one. This is 1, this is 2, this is 3, right? There's 4 numbers here. So this counts to 3 and there's 4 numbers. So if I think about it, um, counting to here, there will be a total of log n minus 1 number. Okay, that's how many there are. And so the total number of values is log of n minus 1 on this one. Now we actually stop merging one ahead of time. Uh, so what that means, oh, sorry, it goes one up. So so to get here, there are a total of log of n numbers, I should say. Okay, to get to this one is uh, log of n plus one. But when we were counting, think about it. We counted this level, this level, this level, up to the n divided by 2 level. We actually never counted the n level because that's completion. So in the end, what we have is we end up with log of n levels of merging. And each of these will cost me c times n. So this is the cost per level. Okay, this is cost of merging at each level. And this is the number of levels. So this is where this comes from. Now, with big O notation, remember, we don't care about constants. So who cares about the C? Drop it. And the whole runtime ends up being n log n. Okay? So that's it for this video. So hopefully this was useful. We'll take another look at another video on quicksort.